Namaste dear students. We have started chapter number 2, Mechanical Properties of the Fluids. In that chapter, we have seen angle of contact in lecture number 5, and in that lecture number 5, we have seen the explanation of the convex meniscus, explanation of the concave meniscus. Now we continue that part here and we explain the zero angle of contact. म्हणजे आपला कॉन्व्हेक्स मेनिस्कस आणि कॉन्केव्ह मेनिस्कसचं एक्सप्लेनेशन लेक्चर नंबर 5 मध्ये आपण घेतलेलं आहे. तर आता त्याचा कंटिन्युएशन पार्ट आहे हा. तर एक्सप्लेनेशन ऑफ द झिरो अँगल ऑफ कॉन्टॅक्ट. फॉर एक्सप्लेनेशन ऑफ झिरो अँगल ऑफ कॉन्टॅक्ट we'll take the liquid which will completely wet the solid, and example of such liquid is highly pure water, and the solid is a clean glass. If you take the highly pure water in a clean glass, the angle of contact will be nearly equal to 0, means that angle of contact tending to 0 for pure water, means for highly pure water. And if you take the clean glass, then angle of contact will be tending to 0, or it is nearly equal to 0. So in first figure, in this figure, a molecule A of the liquid, liquid is shown by the red portion. Molecule A of the liquid on the surface in contact with this solid has the sphere of influence. This is the sphere of influence of molecule A. Then vector AP shows the adhesive force. It is the adhesive force between molecule A and the molecules of the solid. And this value of the adhesive force vector AP is very large in case of the water. And if you see this red portion in the sphere of influence, this red portion is the molecules of the water. Molecules of the water are very small in number, and because of that, the cohesive force which is on molecule A will be nearly 0, or it will be negligible. Negligible cohesive force will be produced on molecule A. Then the resultant vector AR, resultant of adhesive and cohesive force, is vector AR, and it will lie on vector AP, because this cohesive force actually it is vector AC. Since it is 0, it is not shown in figure, and resultant of vector AP and vector AC is vector AR. It will lie on vector AP, and to make this resultant vector AR perpendicular to the tangent, this tangent lie on the surface, solid surface inside the liquid. म्हणजे हा जो रिझल्टंट असतो वेक्टर AR हा टँजंटला परपेंडिक्युलर पाहिजे स्टेबल कंडिशन मध्ये, आणि मग परपेंडिक्युलरला येण्यासाठी ही जी टँजंट असते ही टँजंट सॉलिड सरफेसवर असते. दिस टँजंट विल लाय ऑन द सॉलिड सरफेस, and because of this angle of contact will be 0. How we measure angle of contact? Angle of contact is measured from the surface of the solid to the tangent. Now here tangent is on the solid surface, and therefore angle of contact is 0, and this is explanation of the angle of contact. Now we see the condition of the convexity and condition of the concavity. Now to explain condition of the convexity and concavity, we consider hypothetical liquid. म्हणजे एक काल्पनिक असं एक लिक्विड आपण कन्सिडर करू, हायपोथेटिकल लिक्विड कन्सिडर करू की ज्याचं angle of contact हा 90 degree असेल. Consider hypothetical liquid of angle of contact 90 degree. And for that liquid in contact with the solid, if we draw vector AC, which is the cohesive force, then this vector AC should be drawn at an angle 45 degree with the surface. If angle of contact is 90 degree, means when angle of contact is 90 degree, then this angle between vector AC and solid surface should be 45 degrees. So draw the AC, means draw vector AC making an angle 45 degree with the solid surface. Then this resultant vector AR will touch the solid surface. It will on the resultant vector AR will be lie on the solid surface inside the liquid, and condition for the stable equilibrium is that vector AP should be equal to AC upon root 2. Means if angle of contact of the liquid is 90 degree, then for that 90 degree angle of contact, this angle between AC and surface will be 45 degree, and condition is that vector AP should be AC upon root 2, and this is for 90 degree. And if angle is less than 90 degree, means it is acute angle, then for acute angle this AP should be equal to AC upon root 2. It should be greater than, it should be greater than AC upon root 2 for acute angle of contact, and for obtuse angle of contact AP should be less than AC upon root 2. AP means this vector and AC means this vector. Means when AP is less than AC upon root 2, then obtuse angle of contact will be formed, and for that angle theta will be greater than 90 degrees. So this is called condition of the convexity. Means when AP less than AC upon root 2, it is condition of the convexity. So this is the end of the angle of contact topic. Now we see another topic, which is the shape of the liquid drop. Now shape of the liquid drop will depend upon the surface tension between the liquid and solid, surface tension between solid and air, and liquid and air. So it will depend upon these factors, and for that purpose we consider the drop which is on the solid surface, drop of the liquid on the solid surface. In this figure, this is the drop of the liquid, red is the drop of the liquid, and this is the solid surface. There are three forces acting on this liquid drop. First force is T1. T1 is the force due to the surface tension between solid and liquid. Means because of the surface tension of the solid and liquid, there will be force which is T1. Then T2 is the force which is due to the surface tension between solid and air. म्हणजे सॉलिड आणि एअर मधले जे मॉलिक्यूल असतील त्यांच्यामधलं जे सरफेस टेन्शन असेल त्याच्यामुळे जो फोर्स असेल तो T2 असेल. देन T3 इज द फोर्स विच इज ड्यू टू द लिक्विड अँड एअर मॉलिक्युल्स. लिक्विड आणि एअर मॉलिक्यूल मुळे जो फोर्स असेल तो T3 असेल. नाउ व्हेन द लिक्विड इज इन इक्विलिब्रियम और लिक्विड ड्रॉप इज इन इक्विलिब्रियम, म्हणजे ड्रॉप असा स्थिर असेल तेव्हा, when liquid drop is in equilibrium, it will satisfy this equation, that in equilibrium condition liquid drop will satisfy this equation T2 equal to T1 plus T3 cos theta, where theta is the angle of contact. Now you can write this equation as T2 minus T1 divided by T3 is equal to cos theta. मॅथमॅटिकली हे इक्वेशन आपण असं लिहू शकतो. नाउ फर्स्ट केस, when T2 minus T1 is less than T3 and T2 is less than T1, in this case value of cos theta is positive. म्हणजे इक्वेशन बघा तुम्ही, T2 minus T1 less than T3 असेल आणि T2 less than जर T1 असेल, T2 ची किंमत T1 पेक्षा जर समजा जास्त असेल, it is greater when T2 is greater than T1, then this value of cos theta is positive. The cos theta ची value ही positive असेल, and when value of cos theta is positive, then the acute angle will be formed. It is shown in this first figure. म्हणजे या फिगर मध्ये हा अँगल जो फॉर्म झालेला आहे हा acute angle फॉर्म झालेला आहे आणि इथं cos theta ची व्हॅल्यू ही पॉझिटिव्ह असेल. नंतर सेकंड केस, when T1 minus T2 is less than T3 but T2 is greater than T1. म्हणजे समजा या फॉर्म्युल्यामध्ये T2 greater than T1 असेल तर याची जी किंमत असेल ती निगेटिव्ह राहील. इट विल बी निगेटिव्ह. सो value of cos theta will be negative and the angle which is formed is a obtuse angle. म्हणजे ही फिगर, म्हणजे या फिगर मध्ये obtuse angle of contact हा फॉर्म झालेला आहे. मग obtuse angle of contact साठी ही कंडिशन असेल T2 greater than T1. म्हणजे T2 ची किंमत T1 पेक्षाही जास्त असेल तर cos theta हा निगेटिव्ह राहील. नंतर थर्ड केस, when T2 minus T1 is equal to T3, म्हणजे हा T2 minus T1 आणि हा T3 हे इक्वल असेल तर cos theta ची किंमत असेल 1. It will be equal to 1 and if cos theta equal to 1, value of theta equal to 0. म्हणजे 0 angle of contact साठी ही कंडिशन आहे T2 minus T1 equal to T3. आणि फोर्थ कंडिशन आहे की जर T2 minus T1 greater than T3 असेल किंवा T2 greater than T1 plus T3 असेल तर cos theta ची किंमत greater than 1 असेल and this is not possible. Value of cos theta greater than 1 is not possible and for that purpose when we take T2 minus T1 greater than T3, if T2 minus T1 greater than T3 means I will write here when T2 minus T1 greater than T3, then value of cos theta is greater than 1 and this is not possible. Means liquid surface will spread everywhere. The liquid surface will spread. So this is the explanation of the shape of the liquid drop. म्हणजे लिक्विड ड्रॉप त्याचा आकार जो घेतो तो वेगवेगळे आकार कशामुळे घेतो तर त्याच्यावर ऍक्ट होणारे जे फोर्सेस आहेत, वेगवेगळे फोर्सेस, त्या वेगवेगळ्या फोर्सेसमुळे लिक्विड हे ड्रॉप जो असतो तो वेगवेगळे शेप घेतो आणि ते वेगवेगळे जे फोर्सेस जे लिक्विड ड्रॉपवर ऍक्ट होणारे ते आपण कन्सिडर केले 3 फोर्सेस T1, T2 आणि T3. हा जो T1 असतो हा फोर्स ड्यू टू सरफेस टेन्शन बिटवीन सॉलिड अँड लिक्विड असतो. नंतर T2 जो असतो फोर्स ड्यू टू सरफेस टेन्शन बिटवीन सॉलिड अँड एअर असतो. नंतर T3 जो असतो फोर्स ड्यू टू सरफेस टेन्शन बिटवीन लिक्विड अँड एअर असतं. आणि जेव्हा या फोर्सचा जो कंबाईंड जो फॉर्म्युला आहे T2 minus T1 upon T3 equal to cos theta, याच्यामध्ये जेव्हा वेगवेगळ्या कंडिशन्स येतात म्हणजे T2 minus T1 equal to T3 असेल तर cos ची किंमत 1 असते cos theta ची आणि अँगल ऑफ कॉन्टॅक्ट 0 असतो. तर अशा प्रकारे आपल्याला लिक्विडचा जो शेप असतो किंवा अँगल ऑफ कॉन्टॅक्ट जे असते ते डिसाइड करता येतात. So this is the explanation of the angle of contact and the shape of the liquid, and That's all for today's lecture. We see next